as we dig deeper into statistics, we're going to use a familiar flavor of this query that we've been seeing as our example. This time we're going to select the ID from posts where last user ID is a literal value, 41071. Let's check out the execution plan that we get, and then we'll look at the estimated number of rows that we're going to get as part of our clustered index scan. If we want to look at statistics in Management Studio's GUI, we can just go to, in our case, the posts table, and then expand the folder that says statistics. Inside there, we find a bunch of kind of cryptic looking names. All the stuff that begins with _WA_sys are automatically generated statistics, stats that are generated when that column is queried. The _WA supposedly stands for Washington, which of course is where Microsoft is based, and the sys just stands for system generated. Let's say we wanted to track down the column statistic that applies to the column last editor user ID. In order to do that, we have a couple of options. Number one, we could go through this list of statistics here and right-click on each one until we find the one we're looking for. That's crap. I'm not going to do that, neither are you. So we've got a better way. We've got a query that we can run. This query will tell us the name of the statistic and the name of the column that it applies to. That way we can very quickly and easily track down what it is we're looking for. Now that we're able to equate the statistic name with the column name, we're getting closer to tracking down that estimated number of rows. From here, what we want to do is run a command called DBCC show statistics. This command will give us more details about where those estimated rows are coming from. When we run DBCC show statistics, we run it for a given table and then the stat within that table that we're interested in. What we get back is a three-part result set. The first part that we get back is called the header. And reading from left to right, here's what the header contains. It has the name of the statistic, the last time it was updated, the number of rows included in this statistic, the number of rows sampled, because it's possible to update or create a statistic without actually reading every row that's available. Steps is the number of buckets or ranges of data that the histogram contains. Density is there for backwards compatibility reasons only. We're going to skip it. Average key length, because this is an integer, everything's going to have a length of 4 bytes. String index simply indicates whether or not this is a string column. In our case, we're looking at an integer, so the answer is no. Filter expression, if there were one, would be here. Unfiltered rows refers to the number of rows in the table or index before any where clause gets applied. If we were looking at the stats on a filtered index, then the number in the rows column would be essentially a filtered rows count. It would be the number of rows that come back after the where clause is applied. Over on the other end here in the unfiltered rows, we see however many rows exist in that table or index before anything gets applied to it. The second part is called the density vector. The density vector contains one very important column, the all density column. Now you'll notice in the header there's a density column, and in the density vector there's an all density. The density in the header is for backwards compatibility purposes only. Ignore it. Don't use it. When you think of getting the density, go to the density vector. That's a lot of saying the word density. In a little while, I'll show you what the all density number is for, but for now, let's keep going. The third and final result set from DBCC show statistics is the histogram. The histogram contains more detailed information about the distribution of data. The first column is range high key. This is the last value in that bucket or step if you were to sort all of the values in that step in ascending order. So looking at line 4, the value of 1228 for the last editor user ID is the last value in that particular step. If row 4's step ends with 1228, then row 5's step begins with the next highest value found in the data. So if there's a 1229 or 1230, that will be the starting point of step 5. Range rows is the count of rows in this particular step. For example, row 4 with the range high key of 1228, in that bucket there are 20,607 rows. The range rows count does not include rows that match the range high key. So if we were to look for all the rows in this step, we would throw out the ones that have the last editor user ID of 1228. The reason for that is that the next column over, EQ rows, is the count of rows that match the range high key. So if we had the range high keys rows in the range rows, we'd be double counting them. Now you may be looking at range rows, EQ rows, and average range rows and wondering, these are row counts. So how can these have fractions of rows? That's not really a thing. Like 20,607.91. What is that 0.91 row? What does that look like? Well, these are just estimates. These are SQL Server's best guess. And rather than clip off the decimal, it just leaves the tenths, hundredths, thousandths in that number. So don't worry about it. It's just an approximation. Distinct range rows refers to the number of distinct values that fall in that particular step. So again, looking at row 4, we see that the high key is 1228. The previous high key before is 476. And since we're dealing with integers, we know that row 4 must begin then with 477. So between the values of 477 and 1228, there are 98 distinct last editor user IDs. Finally, the last column is average range rows. And this is simply some math involved that takes the number of range rows and divides it by distinct range rows to give you an idea of, on average, how many rows belong to each of the distinct values. With row 4, we just take the 20,607 divided by 98, and we get the 209. Now that we've seen SQL Server's not-so-secret hiding place for statistics, let's go see how the cardinality estimator takes the estimate and the query side by side and puts the two together. Back to our query, we are looking for last editor user ID of 41071, and we want to match that up with the estimated number of rows of 4449.85. In order to do that, we're going to go to the histogram. Histogram? Quickly, to the statmobile! So, yeah, you probably heard about the Statmobile by now. Well, the show must go on, so I jumped on the back of an ice cream truck. Wasn't going very fast, made a lot of stops, but I did get here. So let's take a look at the histogram. Here are the numbers side by side. We've got last editor user ID 41071, estimated number of rows 444985. Where in our histogram do we see those numbers? Aha! There it is. And it's under EQ rows. If you happen to look a little bit over to the left, you'll notice that the range high key, 41071, also shows up in this particular histogram. That means that we happen to hit the range high key with the value of our parameter. Because we hit the range high key right on the money with that value, the cardinality estimator uses the EQ rows column value. Now you're probably saying to yourself, well, that's convenient. That range high key just happened to match the parameter value we chose for this example. They just happen to have 41071 right there in the histogram. Fair enough. Okay. So let's see what happens then when the value that we have for our parameter doesn't match anything in the range high key column. Let's take a look at how SQL Server will then approximate the number of rows for something that isn't listed anywhere, but is part of one of those histogram buckets. Okay, let's take a step down now, and instead of doing 41071, which was right on the money in terms of our range high key, let's drop down a step to 41070 and see what happens. 41070 does not have a value listed in the range high key, so how is SQL Server going to find it? Well, we have to go to the bucket that contains 41070. When we do that, we see that the average range rows is the number that gets called. Okay, so here's the query again, 41070, and we'll get the execution plan, and the estimated number of rows this time is 213, 213.553 to be specific. If we were to go back through the histogram again and locate this number, obviously it's not going to be in the EQ rows because we've already found that that only matches up when you hit the range high key exactly. So where do we find it in the histogram? Right, it's in the average range rows. This is SQL Server's best guess as to how many rows might there be for any given value that falls in this step. Because SQL Server has to divide the histogram into 200 steps or fewer, it can't possibly get the exact number for every row, hence the average range rows. So in this case, we looked up 41070. That falls in the same step that has the range high key of 41071. The average range rows, 213.5528. We've seen now how the cardinality estimator will gather estimates based on the histogram. If the value that it's referencing happens to match the range high key, then it will use the EQ rows column. If it doesn't match the range high key, it will use that step's average range rows value as the estimate. There are times when the cardinality estimator is blinded from seeing what parameters are coming in. It's unable to use the histogram because it has nothing to reference in the histogram. When this happens, the optimizer turns to the density vector, not the histogram, to get a shot-in-the-dark guess at how many rows might be coming back. The math behind the density vector is really pretty simple. We have 15.9 million rows in our table. We have a density vector of 3.25 minus 5 decimal places. We just multiply those two together, and that gives us our estimate, 520 rows. So if the cardinality estimator can't see what value is being passed in, and we ask it how many rows are coming back, it can't use the EQ rows or even the average range rows. It has to be even less precise and use a density vector. And in this case, it tells us 520 rows. Okay, here's your TLDR. Too long, didn't read. Now that doesn't make sense. Maybe TLDW? Too long, didn't watch? Okay. Statistics are created for every column and index on a table. If we want to look at these statistics, we can either access them through Object Explorer in Management Studio or by querying them directly. If we want more detailed information about a particular stat, we can use DBCC show statistics to get more information back. When we do that, we get a three-part result set. The first part is the header, which contains summary information, like when it was last updated and how many steps there are in the histogram. The other two parts are the density vector and the histogram. The difference between them is, if the cardinality estimator is unable to see what value it needs to compare against when gathering the estimated number of rows, it will use the density vector and do some math against that to figure out how many rows it will get back. If it is able to get a value to compare with, it will go to the histogram. If the value it's comparing against matches a range high key value, it will use the EQ rows column. If it doesn't match the range high key, it will find the appropriate step in the histogram and instead use the average range rows. We've gotten to see single column stats in action now, and we have an idea of how SQL Server comes up with estimates of how many rows it's going to get back based on those statistics. Okay, but what if there's more than one column involved? It's not every day that we get queries that only have just clustered indexes and a single column involved in the where clause. When this happens, we need to look at multiple single column stats at the same time. That's what we're going to look into next.